on the time perception of aging. So a lot of times people say, like, as I get older, the years seem to go by faster. But we all know logically that that's not the case, and that each year is exactly the same amount of time as the previous year in your life, and all of the years you live are equal. But they feel different in your mind. So why is it that we perceive that difference? So what I first did was I looked at how each successive year was different to the total amount of years that you've lived. So if you're 1 year old, that was 1 year out of 1 year that you've lived. Can you see the black marker? So that was 100% of your life. But in your 5th year, that is 1/5 of your life, so that's 20% of your whole life was that 1 year. 10, 1/10, it's even worse. 10%, 25, 1/25 is going to be 4%. So it starts, each year starts getting smaller and smaller as you get older, even though it's the same kind of year. So you really can't see that, but.
Here you go, Ansley.
Thank you.
Yep.
So 50, 1/50 is about 2%, 75, 1/75, 1.33%. But it starts to level off as you keep going. So the average year that you die in America is 79. So I ended at 79 because. With this, I have my Y value being in percentages. So 100 is going to be my maximum value, and 0 is going to be my minimum value. But you're never technically going to have 0% of your life left. So you're just going to get infinity amount closer and closer to the point where you die. So you'll never reach 0. And on the X value, you suppose that you never really have 0 years of life. So you're also going to get infinity far away from your birth, but you never will have an actual year 0. So you'll have, in this equation, to model this, we'll have asymptotes at both x equals 0 and y equals 0, and that's modeled by the parent form y equals a over x, where I'm going to find my standard a. So this is what the equations end up looking like. This is the parent function, y equals a over x, when a equals 1. But to model my function for the 100%, I moved the graph with the shift from the standard 0.11 to 1/100. So at the end of your first year of life, that was 100% of all the years you've experienced. And we don't live forever, so my new domain and range will be 0 to your 79th year when you are, I'm going to say that you're going to die, and 0 to 100% of your life. So this is the whole graph for it, for y equals 100 over x, and it shows how quickly you start accumulating your years of your life, and it starts to level out here. So each year is a smaller and smaller change, really becoming prominent in this area. So rapid doubling and tripling, and these are smaller and smaller proportions. When you find the derivative of that equation, it's going to mean the rate that each year adds to your total life experiences, and that has a separate data point selection. And this slope is all in a negative quadrant, which means that each time, so you're adding years negatively, even though you're technically getting older and older. So at 1 year, you're at a negative 100 area, so you're adding that rate really, really quickly. At 5, you're negative 4, 10, negative 1, 25, negative 0.16, 50, negative 0.04, 75, negative 0.018, and 79, you're at negative 0.016. So you're adding all of these years to your life, but by the time you're older and older, you can't really you have already lived so many percentages of your life that your last year feels really, really small in proportion to everything that you have experienced. So it's more negative, so more change in the beginning of your life, and towards the end of your life, smaller changes year to year feel like there's been less change to your life in the previous year. Any questions?
You said that the average death happened at age 79. Is that including deaths at childbirth?
No. So obviously this is assuming a lot, because if I was to die today, I would stop here. Let's see how long it would stop here. So an appropriate x-axis change would just be in terms of birth and death, and then life in between. But to measure it graphically, you have to put in figured numbers. So you could also do another percentage on the y-axis, so it could be 100% of your life that you've lived and 0% of your life. But it's hard to impose until after you die.
Did you come up with this question topic on your own?
Yeah, my dad and I used to talk about it a lot and like try to figure out why, and that's what we kind of decided.
This is so cool. This is such a good idea.
Any more questions?
How'd you find the derivative?
Well, that was a complicated process. So let me see if I have it. I'm probably gonna get it wrong again. But yes, here we go. So what you have to do to find the derivative of it's a rational function. So you have y equals 100 over x, and that doesn't have any powers to bring down. So you change it to, there's a rule that's y equals, this is the power rule, goes to y prime equals n x to the n minus 1. So you have to change this into a power. So you bring it down to 100 times 1 over x equals y, and you take this out of the denominator. So you have negative 100 times negative 1 x to the 1, negative 1 minus 1. Here. So you have negative 100 times x to the negative second, which is the same as negative 100 over x squared, which is this equation. And